Hey everybody, I just wanted to make a short video to cover the last page of notes from class. I know we went through that parabola example pretty quickly, so I wanted to give you another shot to see it. Also, I thought I'd go ahead and run through the other example as well. So let's start with that one. The question is to find the equation of the line passing through the point 2, -5 and perpendicular to the line y equals -3/2 x plus 17. I'm also going to do parallel just to be complete. So let's do the perpendicular one first. So for the perpendicular line, if this line has a slope of -3/2, our line has a slope of positive 2/3. Additionally, it goes to the point 2, -5. So we know that our line should look something like y equal to m, so 2/3 x plus b. To find the b value, we're going to plug in 2 for x and -5 for y. So if I plug in -5 for y and 2 for x, I end up with -5 equal to 2/3 times 2 is 4/3 plus b. And I'm going to change that to a fraction. Use the denominator is 3. So I'm going to multiply by 3/3 and get -15/3. So -15/3. I'm going to subtract 4/3. And that's going to equal b. So -15 minus 4 is -19. So our b value is -19/3. And then our equation is going to be, for the perpendicular line, that's a symbol for perpendicular, y equal to 2/3 x plus -19/3, which I'm just going to say minus 19/3. To do the parallel line, which we often use this symbol for parallel, the slope should be the same. So our slope is going to be -3/2. The point's still 2, -5. So what I'm going to do, I'm actually going to do this the other way using what's called the point slope form. So instead of doing y equals mx plus b and then plugging in the x and y values to solve for b, I'm going to say that we know the form, the point slope form, which I guess I'll write it up here. The point slope form is literally for when you know a point and a slope. It's y minus the y coordinate that you know equal to the slope times x minus the x coordinate that you know. So this x1 and y1 are known values, whereas the x and y are the variables. Also, interestingly, if you divide both sides by x minus x1, you get the slope formula. So this is really coming from the slope formula. Y minus y1 over x minus x1 equals the slope. Kind of neat. Anyway, so what we're going to do is we're just going to start with this. So we're going to say y minus the y coordinate, which is -5, equals the slope, which is -3/2, times x minus the x coordinate, which is +2. We don't usually leave it like this because we like to kind of simplify. Also, it's just, we usually like to write it in the mx plus b form. So here I'm going to have y plus 5. I'm going to distribute the -3/2 to each term. -3/2 times x is -3/2 x. And -3/2 times -2 is going to be +3. Then I'm going to subtract 5 from both sides to isolate y. So I'm going to have y plus 5, or sorry, I'm subtracting the 5, y equal to -3/2 x. And then 3 minus 5 is -2. So that would be the equation of the line that is parallel to the given line going through that point there. All right, let's revisit this completing the square parabola question that we did in class. I know I ended it very quickly. So to complete the square, you take your first two terms, and whatever the coefficient of x is, in this case it's -4, you divide that coefficient by 2, and then you square it, and then you add that, whatever that is. And it's always going to be adding it because it's always going to be positive. -4 divided by 2 is -2, and -2 quantity squared, or -2 times -2, is +4. And then you can either just say, well, I need to have a -5, so I need a -9 to account for that. Or you can do what I did in class, which is then also subtract 4 and then put in the -5 there. So then we rewrite this, we kind of section this part off. That's your completed square part. That's going to, in fact, let's write that there. That's your completed square. which we'll do more of in class when we talk about circles. So we end up getting y equal to, let's see, that's going to be, and here's a fun tip. It's always going to be something squared, and then -4 minus 5 is -9. And the reason, and the thing that it's always going to be in there is going to be x plus whatever that number is. So in this case, it's x plus -2, or we would write x minus 2. So that's always going to be what you get. X minus 2 squared is, let's double check. X minus 2 squared is x minus 2 times x minus 2. And if you FOIL that out, you get x squared minus 2x plus 4, which is x squared minus 4x plus 4. So that does check out. So here's my parabola. The vertex, this is written in vertex form. So we can see the vertex has an x coordinate of 2 and a y coordinate of -9. You also could have used the original parabola to find the vertex. I know the question doesn't say to do that, but just to point out, you would get the same thing. Right here, if you know that a is 1, b is -4, and c is -5, your Vx would be -b over 2a, which is -4 over 2 times 1, which is 2. And then you would plug that back into the equation to get the y value of 9. Oh, sorry, -9. It is not a coincidence that when you complete the square, you're also doing -b over 2a, right? That's what that is, -4 over 2 times 1. And then to find the y-intercept. So if you look at the original form, the y-intercept is -5. Plug in 0 for x, you get 0 minus 5. But if you use the completed square form, you have to be a little bit more careful, right? I've seen people use the completed square form and say, oh, the y-intercept is -9. It's not. The y-intercept would be, well, if x is 0, you get y equal to 0 minus 2 squared minus 9, which is 4 minus 9, which is -5. So filling a few things in here, I've got that y-intercept, I've got my vertex down here at 2, -9. And then find the x-intercepts. There's a couple ways to do this. I might need an extra piece of paper here. So in fact, let me pull out an extra piece of paper here to make it very easy to see what's going on. So my equation is y equals x squared minus 4x minus 5, which we have also written as y equal to x minus 2 squared minus 9. So a couple, oh, sorry, you want to see that. So if I was doing it this way, right, I would set this equal to 0, right? Because we're, again, if we're finding the x-intercepts, we're going to set y equal to 0. And from here, if 0 equal to x squared minus 4x minus 5, it does factor x minus 5 times x plus 1. And if we set that equal to 0, we get x equal to 5. We set that equal to 0, we get x equal to -1. Alternatively, if you look at it this way, if you set that equal to 0, you can certainly multiply that and get back to here. But the kind of idea, not the kind of idea, the actual idea is that we can add 9 over here. And then when something squared is equal to 9, the something is either plus or minus the square root of 9. Because if x minus 2 is 3, 3 squared is 9. If x minus 2 is -3, -3 squared is still positive 9. So when I square root both sides, I end up getting x minus 2 equal to plus or minus the square root of 9. If I add 2 to both sides, I get 2 plus or minus 3 is equal to x. 2 plus 3 is equal to 5. 2 minus 3 is -1. So that's how we're getting the same thing either way. Yeah. So our x-intercepts, we set y equal to 0. We ended up getting x equal to +5 or -1. Let's see here. So let me graph those. -1, +5. Let me try and plot this thing. I might do this. So there's this kind of neat also fact, piece of information, technique, where I know that this is the middle. So if I go up this high, I go over 1, 2. If I go up this high, I go over 1, 2. So I could also grab that point there if I wanted to make the graphing a little bit more beautiful. Let's see how it turns out. It doesn't have to be perfect. as I'm sure I will evidence many times. The last thing I wanted to say, which I think is also kind of worth noting, is that there is another way that people like to think of completing the square. Is that what I really want to say? Which is the following. So if you, again, right, if you have like y equal, oh, I think it's, yeah, sure. X squared minus 4x minus 5. People like to add the 5 over here. So I've got x squared minus 4x. I'm going to add 4 to both sides, right? Completing the square here gives me a negative 4 over 2 quantity squared. So I'm adding 4. But if I add 4 on one side, I have to add 4 to the other side. 4 plus 5 is 9. So I get y plus 9 equal to x squared minus 4x plus 4. So y plus 9 equals x minus 2 squared. And then you can bring that back over. That's another way people like to do it. It's never been the way I've thought about it, but it does totally work. You can also kind of quickly get to the quadratic formula from this, which is kind of neat, but that's a discussion for another day. All right, I hope you find this helpful, and I will see you all on Monday. Bye.